Thank you so much, and it's such an honor to be here with my co-presenters and an honor to be here at the VMware campus. I work for Pivotal, so we are very close partners, part of the VMware and Dell Technologies family. And I'll tell you a little bit more about myself to start. I was historically a developer, so have a degree in computer science and spent most of my career, I've been doing this for about 30 years, doing software development. I wasn't so much an ops person, although there's a bit longer of a story. When you work in platforms like Cloud Foundry, you very quickly become an ops person as well. I've worked in web architectures, cloud native, Cloud Foundry for quite a number of years. And more recently, I am just about to go to print in my first book, which I've been writing with Manning. It's an architecture book that is supported by code samples as well. So I still get to cut code, though mostly on the weekends. And we are literally just in the final stages of production, and they tell me it's going to go to print in like May 16th or something like that. So it's going to be there very soon. So what I want to start with is I want to start with a quote from a customer of mine. So it says major US telco provider. That telco provider is Comcast. The individual who gave me this quote is a gentleman by the name of Greg Otto. He's been our champion there for the last 4 or 5 years. I've been working with him on their journey to cloud native applications and cloud native platforms, specifically using Cloud Foundry. And more recently, I tend to work on emerging technology for Pivotal and try to figure out how to take that emerging technology and tie it to business value. And that's really what this conversation today is all about. And what he said is, hey, Cornelia, listen, the reason I want to move to Kubernetes is that I want to move all of my workloads from V, virtual, to C, containers, so that I no longer have to worry about things like patching operating systems. So you might be thinking, what? Patching operating systems, containers, what does that have to do with one with the other? And that's what I'll explain as we go along. But before I jump into that, there is another little thing that I want to share with you, and that is that he went on to draw an analogy, which I think is really, really interesting. And that is the first part of the title of this talk. It's the P to V part. It's the physical to virtual part. So here we are on the VMware campus. VMware is the company that really launched this infrastructure virtualization technology. More than 20 years ago, they've had their 20-year anniversary. And in the beginning, I was one of the first people who used VMware's technology, VMware Workstation, and because I'm a developer. And before we had VMware Workstation, I had a laptop and I had 2 hard drives for that laptop. Anybody else? Mm-hmm. Yep, right? One of them booted to Windows. So if I was doing email, PowerPoint, Word, I'd pop that hard drive in and I booted up and I did my work. And the other one booted up to Linux so that I could do my development. Well, VMware came along and developers were the first ones to embrace that technology. And so that we didn't have to carry around 2 hard drives, so that we could have multiple environments, so that I could write software that compiled on Linux and maybe also compile it on a Windows operating system, make sure that it worked across these different environments. So devs were kind of the first embracers of VMware technology. But I would argue, and Greg would argue, that the real business value, huge business value, developer productivity, definitely business value there. But really where it started to go asymptotic, really scaled, was when it hit the data center. And VMware did not build a $10 billion business out of me not having to carry around 2 hard drives, right? So they got that when it hit the data center. So that's what we're going to talk about here. What's really interesting is with container technology, we're seeing a very similar path in that developers were the first ones to embrace containers. And I was just sitting at lunch chatting with some other, some industry colleagues who said, yeah, we're doing Kubernetes and Docker, and it's to power our QA and it's to power our release cycles. It's the developer workflows where containers are being used. But what I want to share with you through the rest of this talk is some of the value that we're starting to see emerge when we move beyond just the developer productivity in containers. So why containers? Why did we start with containers in the first place? And there's really one, and here's my punchline, there's one reason that containers initially became popular. And that was when the software operator on the left-hand side very angrily said to the developer on the right-hand side, your code does not work. And what does she say? Worked on my machine, right? So it works on my machine. And so containers, initially, the very first use case, when I started talking to customers 5-6 years ago about containers, they were the one, this is what they came up with. They said, hey, I want to change that whole barrier between dev and ops. I just want my developers to create containers and ops to run them. It's a lot more complicated than that. We only have 20 minutes. I won't go into the details. But we have to do better than that, and I'll talk a little bit more about those. So if that was the only value, we wouldn't be standing here talking about containers and about Kubernetes today. But the value goes beyond that. So let's go back to Greg's quote. And Greg said things like patching operating systems. So I'll tell you first about this one, what he means by this. And by the way, the reason that he knew about this wasn't that he's this wizard, it's that for the last 5 years he's been deploying Cloud Foundry, which is a container-based platform. So he's achieved a lot of what I'm going to be talking about here, even before he moved into Kubernetes. All right, so let's talk about what he means by patching operating systems. So for those of you who are a little less familiar with containers, here's the basic schematic. We have a host, a virtual machine. Let me take a moment to emphasize that when I say moving from V to C, from virtual to containers, I'm not saying get rid of the V. The V is still there and still plays a hugely important role. Just like physical didn't go away when we went to virtual, virtual doesn't go away when we come to containers. And so right here, you see where the V still comes in. I have a host. And that host has a kernel, has an operating system kernel. And then inside of that host, I create a container. And inside of the container, I add a little bit more operating system, so what we call the root file system. Then I add the runtime layer, let's say the JDK, for example, or the Python runtime or something like that. And then I add the application layer, the actual application that's going to be running inside of there. And that's what it looks like. Now, everything is running fine. I've got this deployed into production. Everything's cool. And then what happens? A vulnerability is found in the kernel operating system. So all of a sudden, we have this vulnerability. Now, the way that vulnerabilities work, for those of you who might not be familiar with this, is that somebody finds the vulnerability and they go to the vendor or they go to the open source project or whatever it is, and they report that vulnerability. Hopefully, it's being reported by good hackers, people who are in the business of finding these vulnerabilities. And now that vendor or that open source project is going to create a patch. They're going to correct that vulnerability. And they're going to make that available to the industry before they announce the vulnerability to the rest of the world. So on a Friday afternoon, they might say, okay, patch is available. And we are going to announce to the world, this is under embargo, we're going to announce to the world on Monday morning